The Twin City Ironworks engine powered the William Box and Lumber Company in St. Paul, Minnesota between 1904 and 1958. It was built with the patented cordless valve gear and boasts a 20.5-inch cylinder bore, 4 feet of travel, and has a 12-foot long connecting rod. The flywheel weighs in at 19,000 pounds and sits on a 7-foot deep foundation containing roughly 250 yards of concrete. During its time in production use, it was the prime source of electricity. It sat idle from 1958 until 1971, when it moved to Rollag and has operated since. The Allis-Chalmers generator produces 240 volts of 3-phase electricity running at 450 RPM. This 460 horsepower engine was running in conjunction with other similar engines and generators at the Sioux Lines Shoreham Yard in Minneapolis, Minnesota. It is a Buckeye steam engine built in 1909 and runs a 300 kilowatt Westinghouse DC generator. It provided power for the rail yard for many years, and in 1982 came to our showgrounds. The project spans multiple years, with the first groundbreaking taking place in 1999. It is a great addition to our showgrounds and lets you see the sheer size of equipment needed back in the day to provide electricity. The Pabst engine is actually not made by Pabst at all. It was a power source at the Pabst Brewery in Milwaukee, Wisconsin. The engine itself is a 1906 Allis-Chalmers 600 horsepower, 2-cylinder, vertical compound engine with cordless valving. The total weight of this engine is a whopping 85 tons. The engine is directly coupled to a 400 kilowatt generator, meaning there is no belt between the engine and generator. When it was in production use, it would generate 3-phase power and 460 volts and operated at 125 RPMs on 150 pounds of steam. This engine and an identical engine were installed in the brewery in 1906 and designed to operate 24 hours a day at 100% capacity. The heat from the low-pressure side of the engine was used for heat in both the brewing process and the building. It was used until 1968, and during its time in production, was stopped only for routine maintenance and suffered no serious breakdowns during its life. It is currently the largest known engine of its kind, still in operation today.
Only goes on right. We're going to be available at 1:30. the belt, we could put in what's called an inside-out twist. So it would not change direction, but would still run with a twisted belt. Oh, looks like that one.
That's all. They're open. This way back. There you go. What's paying attention, Jacob?
Is the pulley on the steam engine. Our pulley is 40 inches. So the RPMs that we'll be calling out here will be a little bit faster than what their end is actually going to be running. But with the mathematics, we can tell how much horsepower is being generated at the wheel. Alright, with a large flywheel like that, I was just told the governor on the engine runs at 210 RPM. So my first guess here is that we'll probably be seeing about 250 RPM. So how is your steam pressure? Are you close to wanting to do anything yet, or do you need to boil it? You want the... Oh, okay. Go ahead and run her up to govern the speed. And then the little device at the very top of the engine that you see spinning around, that is the governor. As he speeds the engine up, you see the balls, fly balls on that governor are actually spinning fast enough, they're moved out away from the center of the governor stem. And that pushes down on a steam valve inside the governor to cut the steam off to the cylinder. As the engine slows down a little bit, the balls will come in because the centrifugal force reduces. That will speed the engine up. That will allow a little bit more steam in. And it will keep the engine at a constant speed as we want, or as constant speed as possible. I'm seeing 270 right now. 56. 56. Yep. So, okay. So, we'll start out at 70 pounds on our scale. We'll get the leading tighten down a little bit. There we go. And need to get the brake warmed up a little bit. There's 70 pounds on the scale, 200, 269, 269. And that's 18 horsepower, so that's not much of a load right now. Let's go up to 100 pounds on the scale. Oh, there's 100 pounds on the scale. You just barely started to hear the engine think about working a little bit. So let's go to 180 on the scale. 180 pounds on the scale. Horsepower.
more Rumely equipment gathered here on these grounds than has ever been assembled before in one place, and most likely there will never be that much Rumely equipment ever any place again. And also, Rumely had been building steam engines for a long time, but I think some of their other competitors were already starting to build gas and kerosene tractors, so Rumely had to get in that business. So they built a prototype kerosene Annie to start out their gas and kerosene tractor business. And there was only one kerosene Annie built. That's what Rumely patterned their oil pull after. But kerosene Annie has been privately owned and been in a museum or in a glass cage, I guess, for the last 40 years. And for this show, kerosene Annie has been restored and running, and we have the kerosene Annie at our show and on our plate. So we are very fortunate to have that. The hammer is powered with steam from the boiler behind you. That boiler operates the big engines in the next two buildings, and it operates that little engine that they're cutting plaques over there. And steam is piped underground and comes up into our steam cylinder here. And the red part's the actual hammer that weighs 1,500 pounds, and that's how this type of equipment was rated, is by what the weight of the working hammer was. And the operator can raise that upper force down with steam pressure. And for making a souvenir plate, we are asking this to give us one hit. We do not want this to pound like the hammer was designed to do. It would not make for a very pretty plate. And for you people on this side, you can't see them, but our operator's controls are on that back corner. Some people think on this day and age that I got a remote button I'm running this thing with, but the operator's back there. Nice equipment survived the scrap man, but a lot of the companies, most of the companies that built the equipment you've seen here have been long out of business. But Morgan Engineering out of Alliance, Ohio, that built this is still in business, and they celebrated their 150th year in 2018. And Morgan kept records of all of their equipment, so you know the name of the purchasing agent for the railroad that ordered this hammer. He ordered it on January 6th of 1892, and we actually have paperwork over there showing that it was shipped February 6th of 1892. It was shipped to St. Paul, so this last February 6th, the hammer turned 130 years old. So when I talked to Morgan Engineering last winter or something, they acknowledged this most likely is the oldest piece of equipment they made that's still in operating condition. Also, with the history we got from Morgan on this particular hammer, it cost them $1,549.53 to build this hammer. And there's 30,560 pounds of iron there. That's why those footings are 10 foot 4 inches deep. And when you do that math for labor and material, that's just barely over 5 cents a pound. That's what it cost them 130 years ago. So what you're going to see right now is we're still in the stamping mode for another few demonstrations. And we're going to see a blank aluminum like this going on the dies. And with one hit, we're going to have our kerosene Annie and our lettering on the plate. This afternoon, we'll be switching dies, and our cookie cutter is sitting out on that far end there now. We'll be moving our stamping die out here and moving the cookie cutter under the dies, and then we'll be trimming these plates around. These said our 47-year collection is on display over there. There's a lot of history on display if you have time to see it. And these plates are sold in that building there, and all proceeds go to make a better show at Rollag. this. I just found out last night, I guess.
That, but I'll get a picture of this.
Making This one is ours.
The Montana boiler has been a staple on our grounds since the early 1970s. Coming to us from Montana, hence the name, it is used to power multiple stationary steam engines on our grounds, like the Pabst, Sioux, Steam Hammer, and others. It has 100 3-inch diameter flues and a large firebox to produce the steam needed to run all of these engines at the same time. Many of our members started their journey to becoming a licensed operator on this boiler. The whistle can be heard across our showgrounds and often a few miles away, especially for the first whistle blow on Friday morning of our show.
When we read our fire, they can kind of see where it's kind of sharp, it's kind of burning good, and then there's places kind of dull. We want to fill in those areas. I had fired about 6 or 7 shallow pools, places off it over. The fire seems to catch up.
Still doing fine though.
Yep, he's still doing it.
He and I became friends It's an amazing device.
Yes, it is.
What's it do?
The first known high pressure steam engine. Everybody knows James Watt invented the steam engine, but he invented a steam engine where steam goes in, condenses, draws the vacuum and does work. This uses high pressure steam to push the piston. We get steam from the big boiler. Everything in this building is run